Let's do this problem right here. The question is asking, let v is equal to 1 3 minus 1 and w is equal to 5 1 1. Find the unit vector in the same direction as v. So it's really simple. Basically, is to find the same unit vector in the same direction. What we have to do is we have to take this vector. So they are asking for v, so I'm doing for v. So take this vector v and divide it by its magnitude. That's all it is. So if I divide it by magnitude, that's gonna give the unit vector in the same direction as v. So in this case, we have 1 3 minus 1, 1 3 minus 1 right here, and in the bottom we are going to take the magnitude of this one. Magnitude is basically the square and square root, so it's going to be 1 square plus 3 square minus, so plus minus 1 square, and if I do this one, I will get 1 3 minus 1 over, sorry, put it in the bracket, so square root of 1 square plus 3 square is 9, 9 plus 1 is 10, 10 plus 1 is 11. So final answer is going to be 1 over square root of 11, 3 over square root of 11, and minus 1 over square root of 11. And that's how it's done. The second question is asking, find x such that the vector 2x x minus 1 3 is orthogonal to v. So what we have to do is, if something is orthogonal, if vectors are orthogonal, it means the dot product of this one should be equal to 0. So that's the condition. So in this case, let's see, if I dot product this one, I can find the x values. That's the question. So if I dot product 2x x minus 1 3 with 1 3 minus 1, so I should get 0. So in this case, if I dot product, so it's simply multiplication adding, right? So 2x times 1 is going to be 2x, and x minus 1 times 3 is going to be 3 times x minus 1. Then 3 times minus 1 is going to be minus 3 equal to 0. And this is going to be 2x plus 3x minus 3 is equal to 0. If I add them together, I will get 5x minus 6 is equal to 0. Therefore, 5x is equal to 6. Therefore, x is going to be equal to 6 over 5. So this is the final answer for that question. And the third question is asking, find all vectors which are orthogonal to both v and w. So to do this one, what we have to do is, we have to take them separately. For example, let's see, x, y, z are the values that are orthogonal. I'm just taking a random vector. So if I dot product this one with the v, 1 3 minus 1 should be equal to 0. And they are asking find all which are orthogonal to both v and w, so I have to take the other one too. So let's take the same vector and y x y z, and then dot product with 5 1 1 should be equal to 0. Some people do like the common mistake is some people just dot product 3 of them together, and that is not the right answer, because if you dot product, you will get a scalar. If you get a scalar, and if you dot product with the other one, it doesn't make any sense, right? So in this case, we have to do them separately and find the values. So in this case, if I dot product the first one, I will get x plus 3y minus c is equal to 0. Then the second one is going to be 5x plus y plus c is equal to 0. Now what I have to do is I have to arrange them in a Gauss-Jordan method. So I have to take the matrix of this one. So in this is going to be 1 3 minus 1 5 1 1 0 0. Now I have to do the Gauss-Jordan. To do the Gauss-Jordan, I have to bring it in that simple form. So in this case, whatever the value below pivot should be equal to 0. So I have to make this one 0. To do this one, I can multiply the first equation by -1 and add it to the second equation. So let's do that. So if I multiply the first equation by -5, it's going to be -5 r1 plus r2, which will give us 0 right here. and if I multiply this one by negative 5 is going to be negative 15 plus 1 is going to be negative 14, and negative 5 times negative 1 is going to be negative positive 5. Positive 5 plus 1 is going to be 6. Positive 6 is equal to 0. Now I had to make this one equal to 1. So to do that I can divide this one by negative 14. So if I do that I will get 1, 3 minus 1, 0 and 0. Negative 4 divided by negative 14 give us 1. And if I divide this one by negative 14, I have to divide this one by negative 14 too. So if I divide this one by negative 14, I will get minus 3 over 7. And that is equal to 0. Now I have to make the values above the pivot equal to 0. So if I do that, I will get, so let's continue in this side. So if I do that, I will get, so to do this one, I had to multiply the second equation by negative 3 and add it to the first equation. So it's going to be negative 3r2 plus r1, which will give us 1, 0, and if I multiply this one by negative 3, this will become positive 9 over 7. Positive 9 over 7 minus 1. Minus 1 means 7 over 7, so minus 7 over 7 is positive 9 over 7 minus 7 over 7 is 2 over 7. 2 over 7, and in the bottom it's going to be 0, 1 minus 3 by 7 equal to 0, 0. Now I can solve the system. So we know this is the free variable because this column doesn't have any pivot, so this is a free variable, so C is free variable, and therefore I had to write everything in terms of free variable. Therefore if I solve this equation, it's going to be x, the first equation is x plus 2 over 7 z is equal to 0, therefore x is equal to minus 2 over 7 z. Then y minus 3 over 7 z is equal to 0. Then y is equal to 3 over 7 z. Therefore I can now write the final answer. So I have to, this is going to be minus 2 over 7 z, and the second one is going to be 3 over 7 z, and the last one is free variable, it's going to be itself, so it's going to be z. So what does it mean is whatever the value you plug, for example 1 or 2, 3 or any number, if you plug this one, that's going to be orthogonal to both vectors. So if you plug any number like 1, 2, 3, you can plug any number, and if you dot product with these two, you will get 0. So this means any value of this is going to be orthogonal to B and W, and that's how we find this one. And I hope you guys like this video. See you next time. So this is C.